In the previous videos, we have seen how to construct the heterogeneous graph using the DGL heterograph method. In this video, let's see how can we add the node and edge features to the heterogeneous graphs. There are two methods we can do this. The first method, we can use the ndata and ddata. So this is very similar to the one that we have already seen for the homogeneous graph. And the second method is to use the nodes and edges methods. Okay, so here I have already taken the heterograph which we have constructed earlier, that is this graph, the graph with three different entities and two different relations. So for this same graph we have constructed the heterogeneous graph using DGL. So I'm just loading the same graph again, which I have stored in the heterograph object. Okay, so this is the graph that we have. We have a director, movie and user edges, and we have two relations between them. So now let's try to add the node and edge features. So just see this diagram here. So this is the same diagram, the same graph, but I just added some additional node vectors at every node and some edge weights on every edge. Okay, so now let's try to replicate the same thing on this heterograph. We already have the graph. I meant to say we already have the nodes and edges. Now we just need to add the node features and edge features. Okay, so let's try to add the node features and edge features using the ndata and edata methods. Okay, so we have already seen this. Anyway, I'll show you again. So we have heterograph. So earlier we were adding something like this, right? Heterograph.ndata. We were giving the vector name or the feature name. So here I'll call my feature name as node vector. Okay. So here I have given it as node vector. So earlier in the homogeneous graph, we were directly adding the tensors of size, the number of nodes into the vector dimensions. But here, this is different. This is not a homogeneous graph. Here we have different types of entities. So in that case, similar to the graph creation, here also we need to pass the dictionary where keys are nodes, values are the node vectors. Okay, so let's see how can we create that. So now I wanted to create this node vector feature for different entity types. So first I'll define the entity types. So what are the node types that we have? So heterograph dot n types will give us all the node types. So we have three different node types. Okay, so first I'll take user. So for user, we need to add tensors. So what will be the size of tensor for user? How many nodes do we have? Three nodes. And what are the dimensions of each of these node vectors? Two dimensions. So we need to create 3 into 2 matrix. Okay, because we have three different users and each node vector is of two dimensions. That's why it's 3 into 2. Okay, so just to keep the things simple, I'll just assign all the node vectors as ones. So I'll write torch dot ones and I'll give the dimensions as 3 comma 2. That is, create three two-dimensional vectors. Okay, and after user, okay, I'll just keep this down. Okay, so after user we have movie. Okay, we have movie. And how many movies do we have? We have two movies, and each of the node vector at movie is of three dimensions. So I'll create a torch dot ones of number of movies, comma the vector dimensions, which is 3. Okay, comma. So the next one is director. Okay, director. So how many director nodes do we have? We have two director nodes and each of the node vector is of two dimensions. So I'll give 2 comma 2 and see, like, these dimensions are very important. Okay, so now I'll just run this. Yeah, so now I'll just print my heterograph. Okay, I'll just print my heterograph dot. I'll just see whether it is applied or not. So we just added the node vectors. Now I'll just access the node vectors using the same using the same syntax. So we can access the node vectors also using the same syntax. So I just accessed the node vectors. So if we just print this, yeah, we can see for director there are two two-dimensional vectors, you can see, and for movie we have two three-dimensional vectors. This is a vector of 3 ones and this is a vector of 3 ones. And similarly for the user we have three two-dimensional vectors. Okay, this is a two-dimensional vector, this is the second 2D vector, this is the third 2D vector. Okay, just to keep the things simple, I'm just assigning ones for all the node vectors, but you can assign whatever number you want or whatever features that you have processed. So this is how we add ndata, that is the nodes data. So now let's see how can we add the edges data. So it is also very straightforward. So we keep it as like heterograph dot e data, and we can give the name. So as it is a scalar, I'll give the name as edge weight. Okay, or edge weights. I'll keep it as edge weight. So here also we need to pass the dictionaries. Okay, here also we need to pass the dictionaries, but here we need to pass the edge type instead of node type. So let's see what are the edge types we have in this graph. So we can get all the edge types using dot e types property. So we have two different edge types, right? So the first one, I'll just put it as watches, and the second one is directs. Okay, now we need to see how many edges do we have for each of these edge types. So for that I'll write hetero graph dot num edges. First let's see for watches. Okay, so for watches we have 4 different edges. So I'll create torch dot tensor. Maybe here also I'll create once. Okay, or we can create tensor, like which we can do anything. Okay, I'll do torch dot once. And how many edges we have? 4 edges, and we need a scalar, so it's a single, like I'll put it as like 1 because we just need one value. Similarly for the director also, let's see how many we have for the directs relation. Okay, so we have 2 edges, so I'll keep it as torch dot ones of 2 comma 1. So let's see whether it will work or not. Okay, yeah, it's done. Again, we can access the edge weights using the same syntax. We can access the edge weights using the same syntax. You can see for this relation we have 2 scalars, right? Because we have 2 edges. And for watches relation we have 4 scalars, right? 4 ones, because we have 4 edges. So this is how we assign the node features and edge features using n data and e data. So this is one way. And the second way is to use the nodes and edges. Okay, to use nodes and edges. So what I'll do for now is that I'll just get this heterograph. So I'll do one thing, I'll just delete these things. Okay, because I wanted to recreate them again. So first what I'll do, I'll delete. So I'll delete heterograph dot ndata of node vector. Okay, I'll just recheck whether it is really deleted or not. So it should throw error now. Yeah, it is empty. Yeah, because I deleted. I'll also delete the edge weights. Okay, I'll also delete the edge weights. All right. So I deleted both. So now I'll print my graph again. I'll print my heterograph. So this is my heterograph. So now I'll try to add the same node vectors and edge weights using nodes and edges. So we already know what are nodes and edges, right? Like on the heterograph, how can we use the nodes? So we can use nodes. Yeah, but it will throw error. We need to pass the node type, that is n type. Let's say n type is equal to user. So this will give us all the node IDs, right? And the same thing we can also access as, instead of function we can access it as like an array. So I'll just remove this. Instead I'll access like this. Okay, but see, This is also nodes, but this is a function. This nodes is a function, but this is not function, because this function will return us the node IDs of this user node, whereas this thing does not return. I mean, it doesn't have anything to return so far. So this is like a node space. We can use this kind of syntax to add node features. So let's see how can we do that. So I'll put, see, if you see, what do we have in this? We have data, right? We have data within this node space. So I'll access that by using dot data. It's empty, right? So this is very similar to what we had earlier. So that is heterograph dot ndata. Okay. And this is like not for the single graph. So how did we define this? So ndata, okay, we don't have anything, but it's a heterograph, so we need to pass the user, right? So heterograph dot ndata of user has an empty dictionary. It's very similar to that. Heterograph dot nodes of entity name dot data also has empty. So these are just two different syntaxes. Either you can use this syntax or we can use this syntax. Earlier we have used this syntax. Okay. So if you see here for the nodes data, so we used this syntax. But here in using this syntax, we were directly adding the data at a feature level, not at a node level. But using nodes, we can add the data at a node level, not at a feature level. So I'll just show you the difference. So earlier, what are we doing? We were doing ndata of node vectors, right? And we were passing the dictionary, right? Dictionary of nodes and the respective tensors. But now we'll do nodes of user. I'm accessing the node first and then we access the feature. Okay. So then I'll put it as node vectors. Okay, node vectors. Now I'll define again. So torch dot once. So how many nodes we have in users? We have 3 users, and I wanted to have what dimensional vector? So I wanted to have a 2D vector, 2-dimensional vector. So I'll put it as 3 comma 2. Okay. So I'll just run this. Okay. Now let's see heterograph dot ndata. Okay. Can you see the node vectors are added now? So using this syntax, we have added node vectors for user. So let's try to add the same thing for all the other node types also. So we have user, then we have what else do we have? We have movie, we have director, right? So we have movie, sorry. So we have movie and we have director. And movie, we have 2 movies and each movie is of 3D vector. And director, we have 2 directors and each director is of 2D vector. So now I'll run this. Now I'll access ndata. Now you can see the ndata, the node vectors are added for every node type. And it's very similar, right? Even if you see the ndata here, the ndata of node vector, like it's same thing. For director, movie and user, we have added the respective tensors. Here also, even if you access the node vectors, it's same. Both are exactly same, just a different syntax, right? It is also giving the same output. So similarly, we can also add the edges data, that is using heterograph dot edges, and we have watches as edges and dot data. Let's say we wanted to add edge weight, and let's add a scalar. So how many edges we have for watches? We have 4 edges, so it will be something like 4 comma 1, because we are adding scalars. Similarly, we can also add edges for the other relation type. So the other relation type name is directs. Okay, directs. And how many edges we have in this relation? We have two edges, so it'll be 2 comma 1. I'll just run this. Now let's see heterograph dot e data. So we can see we have an edge weight here, right? So we can access edge weight. Okay, right now we can see the scalar values for the directs relation and the scalar values for the watches relation, and this output is exactly same as the output that we got earlier. Okay, so these are the two ways to add and access the node features and edge features. Okay, adding its like two syntaxes, just to be clear. The first syntax is by using ndata and ddata, and here is by using nodes and edges. And for accessing, here we were using ndata, and here also we were using ndata and ddata. Let's see whether we can access these node features and edge features using the same syntax, that is using this syntax. Okay, so let's see, instead of accessing by ndata, let's try to access by the same syntax. Okay, see, it is also giving, right, for the user. So if you wanted to access at a at a node level, you can access in this using this syntax also. Similarly, even you can access the edges also using this syntax. So depending on your task and the problem that you are solving, like we can choose any one of these methods. Either we can now add and access using ndata and ddata, or we can add and access using nodes and edges. Okay, thanks.